Okay. Good morning. So the exam is Friday. During the exam, you'll have your camera on. I need to be able to see you, so make sure your camera is on. It's not facing the ceiling. I need to be able to see you. You can use your notes. I have formula sheets put up there. You can print those or have them open. I think it's easier if they're printed, but that's up to you. So the exam is Friday, February 17th. A couple students had class right after this class, and they were worried about not getting done and then getting to the class because it was an in-person class. So I told them I'd open the class early. So our class is at 10, but you can start it at 9 or 9:30 or come in 15 minutes early. That's up to you. So if you want to enter Zoom early, the password will be up there and you can start the test. I have a class from 9 to 10, but my aide will be in there supervising. So you can start it early. It still is timed. It says an hour and 15 minutes because I figured an hour for the test and 15 minutes if you needed trying to submit it, depending on how slow the computer's working. I don't think it will take more than 45 minutes at the most, but that way then you know you have the time. Now, if you are taking more than the hour and 15 minutes, don't worry about it. Just stay in there, and it may not let you submit it, so then you just email me it. So you email me it and then get off the computer, but you want to stay on Zoom until it's submitted. Any questions on that? This is on As You Learn. It's has the formulas and the rules, and we talked about it last class. It kind of tells you everything you need to know. So like be able to convert, if there's certain things you want to remember about how to do it, you could put it there, like make sure one unit's on top and the other one's on the bottom. Significant digits, I put the rules here so then you can check them. And then there's other formulas. Net flow, draw a diagram if there's a note you want to put about that. Residence time. And we've used almost all of these so far. We haven't done like the last half. So those are formula sheets. There's also the conversions to know. When I was typing, somehow I put a 19 here. This should be 10. I fixed it, but if you printed it before I fixed it, just make note that that should be a 10. And I also put this when I ask you to use humanization values or humanize the problem. You'll choose from here. Any questions? On the review, we had done 1 through 9 last class. Right now on the exam, I have 10 problems. But I'm going to take the test and see, because a lot of them are conversions. And if you can do one, you can do another. So I may shorten that. I'm kind of torn. Do you leave more of the simpler problems that way? If you mess up one of the other ones, then you still have more points. So I'm going to take the test and see. Okay, number 10 is the one we were on. But is there any questions before we start it? A US dollar bill is 0.0043 inches thick. Convert this to meters and express the result in scientific notation. Well, meters, and we have inches. We know feet to meters, and we know inches to feet, so we could make inches feet and then feet meters. So you want to find out what they have in common. If you can't go right from inches to meters, find out what unit you know both ways. And we know an inch, 12 of them is 1 foot. But then you need to decide which one to put on the top and which to put on the bottom. If I put feet on the bottom, then these are not going to cancel because inches, I'll have inches squared instead of canceling them. You have to have it on top and on the bottom. So that tells me I need to put inches on the bottom, since that one's on the top, and I know 12 inches is 1 foot. You should know feet to meters, but it is on the numbers to know sheet. One meter is 3.3 feet. Were we going to meters? Yeah. So 1 meter, 3.3 feet. Again, feet is on the top, so I want the 3.3 feet on the bottom. Notice the inches cancel, feet cancel, and it leaves me with meters. Any questions on that? We take our decimal and divide by 12 and divide by 3.3. This E is a 10, so it's 10 to the negative 4. It already put it in scientific notation for me. I'm going to go 2 decimal places. So this 8 is going to round to a 9. So this is your scientific notation. If they want a decimal form, this is negative, so this number gets smaller. So it starts here and it would go 1, 2, 3, 4. Any questions on that? Number 11. A human being needs approximately 12 kilocalories of food energy per pound of body weight. So 12. In order to sustain life for a day. The planet-wide average body weight of a human is 140 pounds. The total human population of the planet can be estimated by this. Estimate the number of kilocalories of food energy required each day by the entire human population. We want to look at what you were given. We were given 140 pounds. We were given this. And the number of people. And we want to know the total calories or kilocalories. Kilocalories. So we're leaving the kilo. If they just wanted calories, remember kilo means 1,000, but it's saying kilocalories, so you leave it. If you're not sure where to start using measurements. They told us that a human is 140 pounds. Pounds is in the bottom. So we need to put it on the top so that we can cancel it. Humans, we want to make this population. And we know that there's 7.5 times 10 to the 9th humans in the population. So you can use units even for those so that you know whether you should multiply or divide. Multiplying. Right, I have 16 in my notes. Oh, I took it out. Estimate the number of kilocalories. I found if you needed to find calories, then you just multiply by 1,000. But is there any questions on that? Thousand, million, billion, trillion. So the human population consumes or should consume 12.6 trillion kilocalories per day. Now it didn't specify what to use, so you could have written it any one of these three. Any questions on that? Number 12. What can you tell me about this graph? What is the stock? What is the residence time? So it says the coffee cup crisis. 500 billion disposable cups are consumed every year, majority of which are not recycled, ending up in landfills. So 50 billion cups. Sorry, 500. are consumed every year, the majority of which are not recycled, ending up in a landfill. So I would say, well, first of all, what is the stock in this example? Anyone?
500 billion.
But the stock is the actual item, so the cups. The inflow, since it says most of them, is the 500 billion cups. So the stock is the item, which would be the cups, paper, and plastic. What else did I ask? What is the residence time? Signature, level of the stock and the flow rate. I don't know if we're given enough to find the residence. Yeah, we don't have enough because we know how many are coming in, but we don't know how many are there. For residence time, you need the level of stock and the flow rate. We have the flow rate, 500 billion. But we don't have the level of the stock. It tells us how long they're in there, though. This would be our residence time. 80 years. So plastic, I was thinking we had to use the formula, but they actually give you the residence time. Is 80 years. Because that's how long it takes to decompose. Paper takes 20 years. So the stock is the cups, the inflow is the 500 billion, and plastic is 80 years, and paper is 20. Any questions on that? So residence time is how long it either takes to decompose, how long before we did a tank, how long before the water goes through the cleaner or the purifier. And that's what it means, how long it sits there in the total amount. And so plastic 80 years, paper 20. And then this would be our inflow. Any questions on that? So there'll be some type of a graph or a chart like this, and you'll need to explain parts about it. Any questions on that? There also will be, I think, a graph. I don't think I put, right now I only have one. These are the two graphs. If I had you graph, it would be one of these. In a poll of what voters in Florida carried out sometime before 2016 election, 45% supported Democrats, 40% supported Republicans, 5% supported Libertarian, and 2% supported Green Party candidates, and the remainder supported others or were undecided. Represent this information in a pie chart. Why is a pie chart a good choice? If we notice what we're given percents. 5%.
Because it's using percentages.
Yep. A pie chart is a good representative with percents. Because then the whole circle is 100%. So 45%, that's almost half. It doesn't need to be precise. So 45% were Democrat. 5% would make half. So 5%. Oops, I skipped one, but we'll go back to it. 5% Libertarian, 40% Republican. That's it wasn't in the middle. That looks better. And 2% Green Party. Other or undecided is the rest. Well, what's the rest? This is 50. This is 42. Then we need 8 more to make the other half. So they need to add up to 100. So it should add up to 100. Let's say they asked, is there any questions on the graph, first of all? If they asked 1,000 voters, how many of them were Democrat? I might give a graph of a pie chart, and that's why I want to make sure, because that's probably a question I would ask. Whenever you're given the percentages, you should be given how many were used. Now, the way they wrote this, they might have done all Florida voters. But if it was a poll before they voted, they probably didn't. They probably did some kind of a survey. So we're going to say they asked 1,000 voters. How many were Democrats?
400.
I think you just looked at the wrong one. This one said Democrats. But it would be,
Sorry.
that's okay. That's okay. You knew how to do it. You just used the wrong one. So the Democrats, I think that was, yeah, Democrats are the 45%. So 45% of the 1,000 voters. Of means to multiply. But remember, you have to write your 45% as a decimal. 0.45. Remember, divide it by 100 or move the decimal to the left 2. So we take the 0.45 times the 1,000. 450 of them were Democrats. Or at least voted Democrat. So you need to write your percent as a decimal and then multiply. So the pie chart was good for this example because pie charts should be written as percents. Sometimes you'll see the numbers in them, but then they're not being properly used. They should be percents. Any questions on that one? The other graph is the bar graph. A bar graph is when your data is not continuous and you have separate units. In this one, the United States produces 315 million tons of bituminous coal, 338 million tons of sub coal, 73 million tons of igneous coal, and 1.6 million tons of anthracite presented in a bar graph. Remember, a bar graph can either go up and down or horizontal. The bars do not touch. And they don't have to be in an order. I am going, which way is better? I'm going to go across because then I can write the words better. So this will be the type of coal, and this will be produced. And we're going from, and it'll be in millions. Millions. Tons. $315, 338.
1.6 to 338 is a pretty big gap. Is on the test, is that gonna be like,
No, they'll be
Okay.
closer. Yeah, because that 1.3 or 1.6 would be way over here. And then the 73. So you could go like that. On a test though, they'll be closer, maybe all in the 300s or all lower. Yeah, there won't be that huge gap. What's interesting about looking at it when we're drawing it though, this gap is a lot bigger than I am portraying it. And so sometimes in science or in when they're writing a paper on it, they want you to think there's not that much difference between them. So they'll show them closer like this. They'll squeeze those units in. And what they can do is just put a little line like this, which means there's a break so that you could see all of it. But then what it does is it's making my bars look a lot closer than they are. Or if I want to show a huge distance, then I am going to show all those units and that it's very high. So that does come into play because this 315 needs to go to here. $338 is sub. So in this graph, they don't look that, I mean, you can tell that this one has a lot more, but it doesn't look as large as it really is. I mean, it's over 300 million tons more. 338 million more almost. So sometimes they will do that with a graph, and you always want to be cautious of the units. Don't just look at the picture. Oh, it's not that different. Make sure you're looking at the units. So right now I have one graph on the test. It would be one or the other. I wasn't sure. Would you want to keep a graph on the test?
For us to make like that, or
Yes. Yeah, it would either be this one or the pie.
I understand the pie chart a bit better.
And the bar graph? Yeah, the pie chart. Okay, now see, the bar graph's not hard either. Actually, I think it's easier because students sometimes get nervous about making sure the percents are even, which it doesn't have to be exact. I mean, as long as your 2% is smaller than your 45%, if the 45% is real small and the 2% is huge, then there's something wrong.
how would we do this on the test? Would we like draw it on our notes and show you, or is there gonna be
Yeah.
like,
So on the test, you'll be given, it'll be, it's up to you if you print it or not, but this would be up on the computer, you would open it. And then you would work everything out on paper, just like you do your attendance problems, and then just take a picture and attach it.
okay,
Oh, how would we print it beforehand? Like print the test or,
Well, you would have to print it once the test would start.
oh yeah.
And that's why you don't need to print it. You can just keep it up there. And that's why I would have like your formulas and everything printed. That way you
Okay.
don't have to go back and forth and you can just keep the test up on the screen.
Yeah, that sounds good. Thank you.
Mhm. So I wasn't sure. I think the graphs are kind of easy. As long as you know what the graph is, it's not, and we only have 2 graphs really. The bar graph, you just list all the items and then you just bring them up to however many there are. Pie chart, just put your circle with your percents. Any questions on it?
that's gonna be 2 of the 13 questions, right?
Right now there's 10 questions and I would probably only put one of them.
Oh, okay,
Right now, there's probably going to be one where you read it and one where you draw.
With the one where we read it, will it be like the coffee cup one, or will it be like are we gonna have to like do any math when describing the chart, or will we just have to like know our terms and describe like what numbers are in the terms?
I think the most you would have to do, most of it would probably be describing. But if you did, I had a pie chart picked out at one point. I'm going between a couple. And what I asked was how many were there? So then you take whatever the percentage is and multiply by how many people were in the survey to get how many picked that one. So that
Oh.
would be the extent. If I had a pie chart, I would have you figure this out.
Okay.
That's kind of a hint of what the graph is. I like the pie chart graph, but I also like the idea of this graph because you see a little bit more of the stock and things. So I'm kind of in between the two. But at most, there's one that you read and one that you make. The two that choices of drawing would either be the pie chart or the bar. Any questions on those? Number 13. Wait, we did 13 and 14 were the graphs. Number 15. Approximate the following quantities to the number of significant figures specified. The current population of the United States to significant figures and the global population to 3 significant figures. So if we looked up the population, I mean, we already have an estimate for it, but I was just having you practice significant figures. I just want to get a bigger decimal. Thousand, million, billion. This is the world. And then the US. Okay, so there's our population for both. Oops. So I looked up both the populations. Now the one says approximate the quantities to the number of significant figures specified. The current population of the United States is this one, and we want to go 2 significant figures. Well, if we only want 2 significant figures, that would be these 2. Because remember, zeros at the end, unless there's a decimal there, are not significant figures. And this one would leave that a 3. So 330 million is a good estimate for the population of the United States. Is there any questions on the? Well, this is a lot lower than the one I have. When I got there. Or maybe that was, I don't know. That's okay though. Now, when you're estimating on the test, if I told you to find like 1.9% of the population is a high school senior, when you're estimating, you can use these. I would take anything from 300 million to 340 million, and then 7.7 to 8 billion for this one. So you're just estimating, but these are on your to know sheet. This was just to make sure you understood significant figures. It would be this. Another way you can see the significant figure, if we write this in scientific notation, so the decimal would go here. 1, 2, 3, 4, 5, 6, 7, 8. If you want 2 significant figures, 1, 2. If you want 3, if you want 4. After that, you'd have to put 0. So we could not get significant digits further than 4 in this problem. So putting it into scientific notation first helps. The only way it fails you is if there was a decimal here. Because remember, if there's a decimal at the end, then these values are significant. They rounded to those zeros. It asks to put this one to 3 significant figures. 1, 2, 3. This 8 will round that to a 9. Any questions on that? Is everyone all right with the significant figures or significant digits?
So any zeros like before that come before the number are insignificant, right?
Correct. All non-zero numbers significant. If there's a 0 between the numbers, it's significant. if they're before, they are not. So this and this have the same number, 2 significant digits. So anything before is not significant. Afterwards, you notice this one has a decimal. This is different from 92. There are 4, yeah. This has 4 significant digits because it's after the decimal. Normally, we wouldn't put zeros after a decimal. So since they are there, that's what it rounded. This is 4 significant digits. This is only 2.
Okay, thank you.
The other one is if there is no decimal, putting a decimal at the end makes that 0 significant. Okay. Any other questions on it? But this is in the formulas and numbers one. It's a good one to have open. That way you can just double check. I think the biggest ones are these 2 to just be careful on. Any questions on the rounding? Number 16. Suppose a shower head pours, suppose a shower head pours 1.5 gallons of water per minute into a tub. The drain has a clog and allows only 0.5 gallons per minute out. What is the net flow? Now, the first thing you want to do when you're looking for net flow is make sure units are the same. If they were not the same, you'd need to convert them. I didn't do that to you on the tests. I just want to make sure you know what net flow is. Net flow is your inflow minus your outflow. So our net flow is 1 gallon per minute. You just subtract your inflow and your outflow. Is this tub at whatever it was, shower or tub? Yeah, it's a bathtub. Is it in an equilibrium?
No,
Correct. What do you have to have for it to be in equilibrium?
the same amount going in and the same amount going out.
Right. So this is not in an equilibrium. I know I asked it on one of them. So I figured not at equilibrium because net flow does not equal 0. So your net flow should equal 0 because you have the same amount going in and the same amount going out. And since it's not, then it's not in an equilibrium. Would this bathtub then overflow, or will the water all drain out eventually?
It'll drain out.
I don't know. Let's see. If this is positive, then it's getting too much water in it. If it's negative, then it's losing more. So if you're getting 1.5 in and it's only taking half out, it's going to overflow because each time you're getting an extra gallon per minute. So this would overflow because there's more coming in than there's going out. When you have a really bad storm and you think about, my brother had a pond in his backyard and there was a huge storm, the whole backyard flooded. His fish, because there was more water coming in than the ground could take out, went into his pool because the pool's lower, but more water coming in than going out, then you're going to overflow. So if it's the other way, then you're going to lose all of your water if there's more going out. Any questions on that? So think about, like, if I keep pouring water in and nothing's going out, eventually it's going to overflow. But those would be types of questions I would ask with a net flow problem. Any questions on that one? Draw a system diagram for a rechargeable rather than a single-use battery. So if we have a battery, and we've drawn or at least looked at a lot of system diagrams, like the shower could also have one where you have the water going in and then you have your tub and the water going out. The battery, it says it's rechargeable. So that means we would have like charge or electricity. Something that shows you're charging your battery. And then it has a full charge. And then we use it. You could call that work. You could call it energy. But you have something coming in, which is from the electrical source, the charge, and then using the battery. So you want to show a flow in the battery and a flow out. And I don't think it goes anywhere but to be used since the problem doesn't state. Whereas if you had a pond, then you could have water that goes into the dirt, depending on what type of pond it is. You have the rain coming in, but you also have evaporation. No, if I wanted you to show all these things, I would have said it in the sentence that there's a pond that has the rainwater coming in, but it also has evaporation and water seeps into the dirt or any other type of like drainage that it would have for an overflow. So then it would have a little bit more into it. This bathtub would look just like this. It would have your shower head bringing the water in, and it would have the drain bringing the water out. But it won't be more than that. It's just a basic making sure your thought process. Any questions on that? '18's kind of long. We'll start that tomorrow. But is there any questions? Okay, if you do not have any questions, I will see you tomorrow. We'll do the rest of the problems and I will take any other questions. Let me go there. Oh, there's only a few more. But it's a good idea if you try these before tomorrow, and then that way you can see what you understood, what maybe you didn't. But we will go over the rest of them tomorrow. And I'll know exactly how many questions are on the test. And I'll let you know. Any questions?
Wait, we can use Desmos on the test, right?
Right. Right. There'll be that one problem, did we do it yet? This one. Oops, here, let me share real quick. This one, where you'll have to graph on Desmos. So you'll do it algebraically and graphing. But yes, you can use Desmos for any, if you want to use it as your calculator.
Oh, okay. That sounds good.
Okay. Any other questions?
Where can I access our class recordings?
Okay.
Because I was trying to find it the other day and I couldn't.
So you have to go into our class first. Don't try and get it from your main screen. And then it's right here, media gallery.
Gotcha. Okay.
Okay. And then it should come up. There it is. And then they'll be by dates.
All right. Good deal. Thank you.
You're welcome. Any other questions? Okay, then I will see you tomorrow. Have a nice day.
Thank you, you too.
You're welcome.